All right, now that we're in chapter 4, let's talk about the main topic of chapter 4, which is one that you're probably already familiar with, and this is all about atoms. So 4.1 basically goes into the model of atoms and where atomic theory came from. So it ranges from the ancient Greeks to some other scientists that basically add to atomic theory and how they discovered atoms and what the structure of atoms are. So atomic theory and talking about and thinking about atoms started with ancient Greeks. And if you look at the text it says on here, it says if you cut a piece of aluminum foil in half and you have two smaller pieces of the same shiny, flexible substance, you can cut those pieces again and again and again. They started thinking, at what point could you no longer divide this aluminum? So if you're able to keep cutting it again and again and again and again, at what point would you no longer be able to do it? So they debated this and they started thinking about this back then in the Greek times. And a philosopher named Democritus believed that all matter existed of extremely small particles that you would eventually get down to that could not be divided. And he called these particles atoms, which is derived from the Greek word atomos, which means uncut or indivisible. Before he came up with this, and before he came up with this concept of atoms, Aristotle and some other Greeks back then thought that all elements were just made of the four elements, all substances, I should say, which are fire, earth, water, and air. Okay, this is what a lot of people believed for years and years and years. But when we started talking about atomic theory and some of the information we're going to talk about in this chapter, we realized that that's not necessarily true and that elements and substances are made out of what they call atoms. So along comes this guy named Dalton, and he comes up with an atomic theory. And his theory was that all matter is made up of atoms, just like Democritus said, and these atoms cannot be divided. There was four major components to Dalton's theory. One, like we just said in the previous slide, all elements are composed of atoms. Two, all atoms of the same element have the same mass, and the atoms of different elements have different masses. Three, compounds contain atoms of more than one element, so two or more. And then finally, that in a particular compound, atoms of different elements always combine the same way. So for instance, H2O is a compound, that's water, right? It's always going to be two hydrogen, one oxygen. It always combines in that same way. There's more than one type of atom in these compounds. When we talk about the scientists that led to the discovery of atoms in atomic theory, we talk about what their model of atoms was. And at the time, with the information that Dalton had, his model of an atom was a solid wooden sphere. So basically, at a molecular level, at the smallest possible particle or an atom, Dalton just thought it was a tiny solid sphere. And he used these tiny wooden spheres to represent that. Says as far as Dalton's atomic theory goes, that a theory must explain the data from many experiments. Because his theory met that goal, the theory became widely accepted. Over time, though, as people started to discover more and more, they found out that, yeah, Dalton was on the right track, but this theory has to be revised a bit to account for new discoveries. So along comes a guy called Thomson, and it says as a key concept, what contributions did Thomson to develop the make to the development of atomic theory? And Thomson's experiments provide the first evidence that atoms are made of even smaller particles or subatomic particles. So yeah, Dalton was good and he was on the right track, but along comes Thomson and he discovers that yes, not only are atoms the smallest particles, but they're made up of even smaller particles, or what they call subatomic particles, which we'll talk about in a second. So the way Thomson discovered this is that first he noticed that when the materials are rubbed together, they gain the ability to attract or repel. So sometimes when you rub materials together, they have an attraction and they stick together. Other times they repel or they push apart. Because of this, we say that such materials have either a positive or a negative charge. If you have two positive charges, they repel or they push apart. If you have a positive and a negative charge together, they have opposite charges and they attract or pull together. So in Thomson's experiments, he set up a sealed tube that had a very small amount of gas in it. Inside that steel tube, what he did is he had this glowing beam go through the tube. And what he did was he put a positive plate on the top, so this was positively charged, and he put a negative plate towards the bottom of the tube, where it was negatively charged. And when he did this, what he noticed is that this glowing beam, which we know nowadays is made up of electrons, or negative charges, bent up towards the positive plate. Well, through doing this, he discovered electrons. Okay. Thomas hypothesized that the beam was streamed with charged particles that interacted with the air and caused the air to glow. He observed that the beam was repelled by the negative charge plate, so it pushed it away, and it was also attracted to the positive charge plate. So for those reasons, the beam must have a negative charge or be composed of those subatomic particles called electrons, because it was repelled away from the negative plate, two like charges, and it was attracted to the positive plate, two opposite charges. Thomson concluded then that all particles of the beam had a negative charge because they were attracted to the positive plate. He hypothesized that the particles came from inside the atoms, and he called these particles electrons. When Thomson had this new evidence, he revised Dalton's model to account for those subatomic particles. Thomson said, an atom has neither a positive nor a negative charge, but there always must be some positive charge in an atom. So his model, instead of a solid sphere, he said that an atom is filled with a positively charged mass, so the sphere of the atom is solid, but it has negative charges evenly scattered throughout it. They called this the plum pudding model, or you can call it the mint chocolate chip ice cream model. You can think of it this way. The chips represent negative charges. The ice cream itself represents the positive mass. So an atom is a positive mass with negative charges spread evenly throughout. And that's what he thought an atom was like. So along comes another guy named Rutherford, and he had even more to atomic theory. It says, what contributions did Rutherford make to the development of atomic theory? Well, according to his model, all the atom's positive charge is concentrated in one spot, the center of the nucleus. Rutherford decided to design an experiment to find out what happened when something called alpha particles, which are small positively charged particles, pass through a thin sheet of gold foil. So it's called the gold foil experiment. Like I said, alpha particles are fast-moving positively charged particles. Based on Thomson's model, thinking that an atom is a positively charged mass with negative charges evenly throughout it, he thought that the mass and the charge at any location in the gold would be too small to change the path of the particles, so the particles would just go straight through. And then when they struck the screen on the other side, it would light up the screen. So what he hypothesized is that the particles would just go straight through, since the positive mass is even throughout with those negative charges. But what actually happened when he did the experiment was this. Some particles went straight through, some particles were deflected, some particles were deflected straight back. And through doing this, he realized that the positive mass wasn't throughout, but it was all concentrated in one part, the center. So when these positive particles didn't hit the center at all, they would go straight through. But if they did hit the center, which was also positive, they would either be deflected to the sides, or they would be deflected even straight back. I just explained this right here. So through this, he discovered the nucleus of the atom, a dense positively charged mass located in the center of the atom. The positive charge is not evenly spread throughout the atom, but is actually located in that small central area. Okay. Here's some assessment questions for you. J.J. Thomson's experiments provide the first evidence of what? Think about what the answer is in your head. B.C. Subatomic particles. J.J. Thomson's experiments discovered subatomic particles, in particular electrons. The concept of an atom is a small particle of matter that cannot be divided was proposed by the ancient Greek philosopher Democritus. Is that true or false? Think about the answer in your head. That's true. He was the one to first propose this, and then Dalton also built on his theory. So the people you want to know from this chapter are Democritus, Dalton, Thomson, who basically discovered electrons, and then Rutherford, who discovered the nucleus of atoms, or the positively charged mass, or protons. That's it for 4-1.